In this video, we're going to talk about creating good test data, what goes into that, and kind of how it works. So I'm going to be using an IF stream, so we're going to read from a file in this demonstration, just because it's a little bit easier to build a bank of good test data inside of a file rather than having to manually input it every time. Excuse me. So let's say that we want to test an average function, and not like a mediocre function, but a function that finds the average of some number. So we're going to write a program that finds the average of some numbers. So we'll go ahead and make an int sum, and let's go ahead and deal with doubles here. We'll make a double sum and an average, and then we're also going to have an int. We'll just call it n, and it's the number of numbers that we're going to read in. And then we're going to say while not fin.eof, meaning end of file. Then go ahead and read in. We'll make a double num right here. We're going to read in that number. We're going to go ahead and do n++. And then we're going to say sum, which means, of course, n is going to start out equaling 0. And then we're going to say sum plus equals num. Not really anything too scary there. I'm going to put this down here just so the flow of the program looks a little bit better. Let me put this right there. There we go. I like that. That looks great. And then what we'll do is we'll say average equals sum divided by n, and then we'll output average of numbers in file. And we'll just output average. And great, that's not too bad. So let's go ahead and create some good test data for this. To start out with, we'll just do something like 1, 2, 3, 4, and 5. Because that's a quick test, we know that the average of those is obviously going to be 3. We run it. There were some build errors. I forgot to set sum equal to 0 at the start. Don't forget to do that. That's how accumulators work. And average of numbers in the file was, of course, 3. So that means that our test data worked. This is all working. That's great. So this is a good example of test data. But it doesn't so much help us. We don't know for a fact that it is working, because that could have just picked a number in there. And so it would be better if we didn't have 3 in there. And let's say we have another 2, and we can change this to 6. And if this still gives us 3, then we know that our average is still working, because it couldn't have just picked a number out of here. Rather, it would have had to produce the average. And so we run this, and we still get the average of numbers in the file is 3. And so now we'll add in a bunch of other numbers, and 5 and -1,000 and whatever, not a big deal. And we can go ahead and run that. And we get the average is some sort of decimal, which it should have been, probably. So we can trust that that's probably working okay. And another way to just test that things are working is if we leave this blank, then it should give us garbage. But is that right? Do we necessarily want that? Because right here, that means that we're doing 0 divided by 0. That's kind of dangerous. And so this is another way of creating good test data that kind of sounds not very logical, is to try and throw all sorts of garbage in here, AFDS, and then when we run it, then it's not going to work. It's going to break. Bad things are happening right now. See, we're stuck in some sort of infinite loop. And so when we're creating good test data, it's important that we test it with correct data, as well as we should throw in incorrect data so that we can see what we need to do to prevent that from ever happening. So if the user were to give us bad data, then right here, we could say if n equals 0, cout there weren't any numbers. And then we can say else, and put the else right around here. And this will make it just a little bit more robust.